Look around you. Everything seems solid, predictable and real. A baseball, when thrown, follows a clear path. A planet orbits its star with mathematical certainty. We call this the classical world, the one we can see and touch, governed by rules that make sense. It's the universe of Isaac Newton, a grand cosmic clockwork ticking away reliably. But if we could shrink ourselves down, smaller than an atom, smaller than its nucleus, we would enter a realm where all those familiar rules break down completely. This is the quantum world, and it operates with a logic that seems utterly alien to our everyday experience. Down in this subatomic domain, particles like electrons don't have a single fixed location. Instead of being a tiny point, an electron exists as a wave of possibilities, a cloud of potential. Imagine it's not in one place, but in all possible places at once. It's a ghost, a smear of probability spread across space. It only chooses a definite position when we try to measure it, when we look. The very act of observation seems to force this ghostly wave of potential to collapse into a single concrete reality. This is one of the deepest mysteries in all of science. Why does the universe behave one way when we aren't looking and another way when we are? This strangeness is not just a theoretical idea, it's a proven fact of our universe, confirmed by countless experiments. Scientists call this wave-particle duality. A particle is both a wave and a particle, a contradiction that our minds struggle to grasp. Think about it. It's like a coin that is both heads and tails at the same time, spinning in the air. Only when you catch it does it land on one side. The quantum world is that spinning coin, a place of pure potential until an interaction forces its hand. This fundamental difference between the fuzzy quantum realm and our solid reality is the great puzzle we are still trying to solve. The implications are staggering. It means that the very building blocks of our universe live in a state of indefinite suspense. Every solid object, every star, every living being is made from these uncertain particles. So how does the reliable, predictable world we experience emerge from this chaotic, probabilistic foundation? How does the universe build a solid brick wall out of ghostly waves? The journey to answer that question takes us to the very edge of what we know about reality itself, forcing us to ask what real even means. It's a cosmic detective story, and the clues are hidden in the fabric of space-time. Faced with the puzzle of the collapsing wave, some brilliant pioneers of quantum physics, like Eugene Wigner, proposed a radical idea. What if the special ingredient that turns possibility into reality is consciousness? What if the universe waits for a conscious mind to observe it before it settles down into a definite state? This concept, known as the von Neumann-Wigner interpretation, suggests that the act of a human, or any conscious being, thinking and observing, is what solidifies the world around us. It's a mind-bending thought, that our awareness is not just a passive witness to the cosmos, but an active participant in its creation. This provocative idea, that mind shapes matter, finds surprising echoes in ancient philosophies. Thousands of years ago, long before quantum mechanics was conceived, ancient Indian texts like the Upanishads explored similar concepts. They spoke of Brahman, an ultimate universal consciousness from which all of physical reality, or Maya, arises. Maya was described as an illusion, a kind of cosmic dream, and the individual mind was a part of the universal consciousness that perceived it. These ancient thinkers suggested that the world we see is a projection of mind, a concept that resonates strangely with the modern idea of a conscious observer collapsing a wave of potential. Of course, this is a highly controversial idea in the scientific community today. Most physicists are uncomfortable with giving human consciousness such a special central role in the workings of the universe. It seems to violate the Copernican principle, the idea that we are not in a privileged position in the cosmos. Why should the mind of a human on a small planet in a typical galaxy have the power to collapse quantum waves throughout the universe? Is a cat's consciousness enough? What about a computer? The questions quickly become complex and, for many, unscientific. Despite these difficult questions, the idea persists because the mystery it tries to solve is so profound. The measurement problem is real. Something turns quantum fuzziness into concrete reality, and we don't know what it is. The proposal that consciousness is the key remains a fascinating, if unproven, possibility. It places us, the thinkers and the dreamers, at the very heart of the cosmic drama. It suggests that our quest for knowledge isn't just about discovering the universe, but perhaps in some small way about helping to bring it into being. Many scientists, uncomfortable with giving consciousness a starring role, have developed other theories to explain our solid reality. One of the most mind-bending and popular alternatives is the many worlds interpretation, first proposed by Hugh Everett III. This theory offers a simple yet dramatic solution. It says the wave of potential never actually collapses. Instead, every single time a quantum measurement could have a different outcome, the universe splits into multiple parallel universes. In each new universe, one of the possible outcomes becomes the reality. Imagine you reach a quantum crossroads where a particle could be here or there. The many worlds theory says the universe doesn't choose, it splits. In one universe, you find the particle here. In another, identical universe, a copy of you finds the particle there. This means there are countless versions of you, living out every possible outcome of every quantum event. In this view, reality isn't a single solid timeline. It's a vast, endlessly branching tree of parallel worlds, and we are just traveling along one of its infinite branches. There's no special role for consciousness. The universe simply contains all possibilities in separate realities. Another line of thinking, known as decoherence theory, offers a less dramatic explanation. It suggests that you don't need a conscious observer or splitting universes to explain why things seem solid to us. Instead, it points to the environment. A tiny quantum particle, like an electron, is never truly isolated. It is constantly interacting with trillions of other particles around it, photons, air molecules, and so on. These countless tiny interactions effectively smear its quantum weirdness away. The information about its wave-like possibilities leaks out into the larger environment, a process called decoherence. This approach explains why a single isolated particle can act like a ghostly wave, but a large object made of trillions of particles, like a baseball, always has a definite location and speed. The baseball is just too big and too connected to the rest of the world to maintain its quantum nature. Its possibilities are averaged out by its environment almost instantly. In this view, reality becomes solid not because of a mind, but because of the immense, interconnected complexity of the universe itself. Consciousness is just a product of that complex reality, not its cause. So, we stand at a fascinating crossroads in our understanding of the cosmos. On one path, we have the idea that consciousness, the very act of knowing, is what crystallizes reality from a sea of quantum possibilities. This view connects our inner world of thought to the outer world of physics in a profound way, echoing ancient philosophical traditions. It grants us a central role in the cosmic story. It's a beautiful and empowering idea, but one that many scientists find difficult to test or accept, as it seems to place humanity back at the center of the universe. On another path, we have theories like many worlds, which preserve the elegant mathematics of quantum mechanics without giving consciousness a special job. The price of this elegance is a truly staggering vision of reality, an infinite collection of parallel universes, with countless copies of ourselves living out every possibility. Then there is decoherence, a more conservative path, which suggests that the transition from quantum to classical is simply a matter of scale and interaction. It's a practical solution that explains why we don't see quantum effects in our big world, grounding reality in physical interactions alone. Each of these theories paints a radically different picture of what reality is. Is it a single universe sculpted by observation? Is it an endlessly branching tree of all possible worlds? Or is it a predictable outcome of complex systems interacting? These are not small details. They are fundamental questions about the nature of existence. The truth is, we don't yet know which map of reality is the correct one. Science is still on the hunt, designing new experiments and pushing the boundaries of theory to find the answer. The search is one of the most exciting frontiers of human knowledge, and that is perhaps the most wonderful part. You don't have to be a physicist with a blackboard full of equations to ponder these questions. Anyone can look up at the night sky, or look at their own hand, and wonder about the true nature of what they are seeing. The universe has left us with the greatest mystery of all, the mystery of itself. And the quest to understand it belongs to all of us. As we continue to explore the cosmos, we are not just discovering what is out there, we are discovering what it means for anything to be real at all.